So I want to tell you some more about exponential functions and just kind of relate them to other kinds of functions, specifically kind of look at how they relate to some other nonlinear functions that you've probably come across by now. So an exponential function looks like this. F of x equals a to the x. Um, so something like this, y equals 3 to the x. So where the variable is in the exponent of some kind of constant like that. Um, and here's what they look like. Let me just get these guys out of the way. Um, and I got this graph from Wikipedia Commons here because I was struggling to draw it accurately myself. But yeah, it's real close to the x-axis like that. And then I'll go through the point 0, 1, and then it just kind of skyrockets all of a sudden. So that's the general shape that takes. So it's like it's kind of like some of the other nonlinear functions in that, well, it's not linear. A linear function will form a straight line like that. Okay. Um, but so the exponential functions are much more like quadratic functions, which will make a parabola like that. See how there's a curve there, just like there's a curve here, which shows that the rate of change of the function is not constant. The rate of change itself is always changing. So uh, here the rate of change is kind of, here it's nothing, and then it's kind of slow, and then there's just a massive rate, the change of the rate of change. That might be a little abstract for you, but just look, yeah, compare these curves. So it's similar kind of thing. Not quite like a parabola though, because a parabola is there's a line of symmetry, so that I could take this side of the parabola and I could flip it over a line. In this case, I just lined it up so the line of symmetry is the y-axis here. I could flip this over and it would line up exactly with the other side. Um, Exponential functions are not symmetrical like that. You can't just flip the side over. Um, the negative side of the exponential function will look like this, where it just gets closer and closer to y equals 0 here. And then the positive side will just completely skyrocket. So it's not symmetrical, but it is similar in that um, it's curved like that. And you might have a cubic function, same kind of idea where there's not a constant rate of change. The rate of change itself is always changing. And the cubic function is also, there's some symmetry here where I could pick a point in the middle like that. I could rotate this side all the way around. It would line up there. Whereas the exponential function is not like that. There's not an easy point of symmetry like that so much. And the point here is that all these nonlinear functions don't form straight lines, and the reason why they don't, or is because they have um, different powers here. Let's see. Like quadratic functions will look something like y equals x squared, and the cubic functions y equals x cubed, and the exponential functions y equals 3 to the x. A linear function will be something like y equals 2x, where there's just an x, a plain old x, not x to the anything. And that's what makes it a straight line. There's this constant rate of change. All these other guys, these rates of change are kind of pretty wild and crazy and fun. So an exponential function is definitely a nonlinear function, and it's got some similarities and differences with other nonlinear functions that you may be familiar with. So there's your kind of long-winded explanation for how exponential functions kind of fit in the big picture, and hope you enjoyed that.